Welcome to this explainer. Right, let's just dive straight into a terrifying biological mystery. And it all starts with an insect bite in the dark. We're looking at a disease that affects millions, operates entirely in the shadows, and honestly involves an evolutionary arms race that's been waging for over 100 million years. It's a crazy story of incredible stealth, microscopic chemical warfare, and a medical detective story that is quite literally unlike any other in history.
So, when you hear the name kissing bug, you probably picture something soft, maybe carefree and cute, kind of like a ladybug. But in reality, its alternate name, the assassin bug, is way more accurate. This is a repulsive, bloated, nocturnal bloodsucker. It creeps around while you're fast asleep, bites you, drinks up to 12 times its body weight in your blood, and then, well, to add the ultimate insult to injury, it defecates right in the wound before just waddling away. It only got the name kissing bug because it prefers to feed on the soft skin right around your lips and eyelids. Waking up to one of these on your face? Yeah, absolutely the stuff of nightmares.
Section 1. The Kissing Bug's Curse, a highly evolved nocturnal predator.
Let's take a closer look at this bug's absolute masterclass in stealth. Locals in South America often call it the vinchuca or barbiero, the barber, and it is perfectly evolved for a sneak attack. You won't even feel it. These insects love hiding in the thatched roofs of rural homes. Once night falls, they don't just crawl down. They actually use their wings to glide silently onto their victims. And how on earth do they find you in pitch black? Well, their antennae are rigged with highly sensitive heat sensors that can spot a sleeping human from all the way across the room. They even have pheromone sniffers. When they finally strike, their proboscis, which is basically a biological spear, injects an anesthetic so you feel absolutely nothing, plus an anticoagulant so your blood just keeps flowing.
But here is the really crucial, kind of gross point. The bite itself doesn't actually infect you. It's the insect's payload left behind that gets rubbed into your bloodstream. See, the bug takes such a massive blood meal that it's literally forced to defecate right there on your skin just to relieve the pressure before it leaves. Later on, as that anesthetic wears off, the bite gets incredibly itchy. You subconsciously scratch it in your sleep, and bam. By doing that, you rub the insect's feces, which is absolutely teeming with microscopic parasites, directly into the micro tears in your skin, or even straight into your eye.
Section 2. A master of stealth. Meet Trypanosoma.
All right, so let's meet the true villain of our story. The payload left behind by that scratch is this microscopic parasite, Trypanosoma cruzi. This ancient invader is heavily armed and totally ready to wage chemical war against our immune system. Just look at its anatomy for a second. It's got this corkscrew-shaped body designed to literally bore into your tissues. It's propelled by a mastigote, this whip-like tail that thrashes around for high-speed movement. But the real game-changer is its kinetoplast. Think of this as a gigantic turbocharged biological engine. It's basically a massively overpowered mitochondrion that gives the parasite a constant, furious stream of energy to navigate your bloodstream.
The very second Trypanosoma cruzi enters your blood, it systematically disables our internal alarms. It literally soaks up our defenses and dodges our cellular sentinels. Our immune system's complement cascade instantly tries to destroy it, right? But the parasite expresses a protein on its surface called CRIT. This acts like a sponge, soaking up a vital human immune protein called complement factor 2, entirely short-circuiting our defense. If a macrophage, our body's sentinel cell, swallows the parasite to destroy it, the parasite doesn't die. It actually loves it. It uses the attack to create a safe little bubble, a parasitophorus vacuole, to hide inside. And to stop our cells from calling for backup, it deploys this microscopic sharpshooter enzyme called cruzane that snipes and suppresses our NF-kappa immune signaling. It's a complete, systematic hijacking.
Section 3. Hijacking the human body. The Trojan horse phase.
Okay, so once it survives the bloodstream, it has to get inside our tissues to multiply. And once inside our cells, it transforms. It builds a safe little bunker where it multiplies until the cell literally bursts. First, it sheds its whipping tail, becoming an amastigote, which literally means without flagella. Sitting comfortably in the cytoplasm of our own cells, it builds a pseudocyst and begins rapidly dividing by binary fission. Within a day or two, this single invader becomes a massive swarm. When it reaches critical mass, the cell ruptures, releasing a horde of newly matured parasites back into the blood to seek out new cells, or, to be sucked up by another kissing bug.
Now, this parasite is incredibly versatile. It basically holds the biological keys to unlock and enter almost any cell type in the mammalian body. But it has a distinct preference, a tropism, for smooth muscle and cardiac fibers. And it's this specific preference for heart tissue that makes this organism so incredibly deadly over the long term.
Section 4. The silent cardiac killer, a ticking time bomb.
Because the acute phase of this infection often goes completely unnoticed, it turns into a literal ticking time bomb. A person might have what's called Romagn's sign, which is a distinctly swollen eye from where the bug feces was rubbed in as a child. But then, they might feel completely fine for decades while the parasite just waits in the shadows. We call this the indeterminate stage. Some of these mastigotes simply halt the replication. They just hunker down inside your muscle tissues in an arrested state, perfectly dodging the immune system, and they lounge in their pseudocyst for years.
The stakes of this hidden disease honestly couldn't be higher. It is drastically shortening lives across South America. On average, a person infected with trypanosoma cruzi loses about 9 years of their life. With an estimated 10 million people currently infected, mostly in areas lacking quality medical access, those hidden ticking time bombs result in roughly 20,000 deaths every single year.
And when the damage finally manifests, it is devastating. The host's heart undergoes catastrophic failure that mimics tissue rejection. We're talking 95% of chronic patients showing cardiac pathology. The parasite slowly destroys the heart's myofibrils, causing severe arrhythmias and eventually massive heart failure. That smooth muscle preference we mentioned earlier, that also leads to awful conditions like megacolon, where the bowel becomes enormously swollen, leading to life-threatening perforations. And the saddest part? There is no cure. Treatments are really only palliative at this stage.
Section 5. The doctor who solved it. Carlos Chagas' 1909 breakthrough.
So who finally cracked the case of this invisible killer? Dr. Carlos Chagas. He was actually deployed to a remote Brazilian railroad town to fight malaria, but he ended up living and working in an abandoned train boxcar to crack this entirely different case. As historical accounts note, he used that boxcar for 2 years as his office and research center. Sweltering heat and uncomfortable accommodations were the rules rather than exceptions, but he persevered. While everyone else was hyper-focused on mosquitoes, Chagas wondered if the massive, bloated, kissing bugs infesting the workers' quarters were actually spreading a disease of their own.
In a matter of months working out of that tiny boxcar, his discoveries moved at lightning speed. He arrived in early 1909. Just weeks later, he cracks open a kissing bug and finds trypanosomes inside its midgut. He then proves it's infectious by transmitting it to lab animals. And then comes the historic breakthrough. On April 23, 1909, a feverish 3-year-old girl named Berenice, who had a swollen eye, is brought to him. He examines her blood and sure enough finds the exact same parasite he saw in the insect. This is a monumental achievement of scientific detective work that still stands completely alone in medical history. Usually, how it works is one scientist finds a bug. Then decades later, someone else finds a microbe, and maybe years after that, someone finally connects it to a disease. But Dr. Carlos Chagas discovered the vector, the pathogen, and the disease all at once, single-handedly, out of a train car. It's exactly why this horrific ailment rightfully bears his name, Chagas disease. I'm going to leave you with this chilling evolutionary theory to ponder. If the parasite intentionally uses its kinetoplast DNA to incite the immune system to destroy the host's heart, making the host weak and easier prey for predators to eat, what does that say about the sheer, terrifying brilliance of nature? Researchers have actually noted that the parasite's kinetoplast has this unique mini-circled DNA. There's some provocative evidence suggesting this DNA might literally insert itself into the human host's genome, tricking the immune system into attacking its own heart tissue. That's why the heart failure resembles tissue rejection. In the wild, if an infected animal's heart is failing, it becomes weak, slow, and incredibly easy for a predator to catch. And by being eaten, the parasite seamlessly transfers to a new host's intestinal tract without ever needing a kissing bug. It's a terrifying thought, right? That this microscopic corkscrew is literally rewriting host DNA to break their hearts, all just to serve itself up on a silver platter to the next predator? Thanks for joining me for this explainer, and stay curious.